Hello students, in this video we are going to discuss about LL1 parser construction. So in previous videos we already discussed about how to calculate the first and how to calculate the follow, and also we discussed about how to remove the left factoring and left recursion. So using these, we need to construct the LL1 parser. Okay, basically LL1 parser, it is a top-down parser. And in top-down parser, there will be a recursive descent parser. There will be two different, backtracking and non-backtracking. And in non-backtracking, it is a predictive parser. This is also called LL parser. So predictive parser is a recursive descent parser, which has the capability to predict which production is to be used to replace the input string. And the predictive parser does not suffer from backtracking. Okay, so it won't suffer from backtracking. So that's why it is called non-backtracking. It is coming under the non-backtracking. Okay, so here, if you are talking about why it is called LL parser and how it will be constructed. Okay, so here it is LL parser, and here it will take one stack as an input. You know what is the work of a stack? It is a last in, first out. Okay, and input also it will be taking input, and here passing table it will construct. Here to action and go to it will perform, and after that it will produce the output. If the string is accepted, then it produce okay, it is accepted, otherwise it will produce the error output. So predictive parsing uses a stack and a parsing table to parse the input and generate a parse tree. Both the stack and the input contains an end symbol dollar. Okay, the stack and input. So both contains the end symbol, that is dollar, to denote that stack is empty and the input is consumed. And the parser refers to the parsing table to take any decision on the input and stack element combination. It will take the decision according to the input string, whether we need to take the action or we need to go to a parsing table. It will do like this. Okay, so here, why it is called LL parser? An LL parser is called LLK parser if it uses k tokens of look ahead when parsing a sentence. Okay, so LL grammars, particularly LL1 grammar, that means only one input it will take as a parser, are easy to construct, and many computer languages are designed to be LL1 for this reason. Okay, the one stands for using one input symbol of look ahead at each step. That means only one input symbol it will scan to make parsing action or decision. So first L represent to left to right. That means from left to right the input will be scanned. And second L represents the leftmost derivation. The tree will construct only leftmost, using the leftmost derivation only. And K is a look ahead symbol. Here we are using one, so only one symbol it will consider. So that's why it is called LL1 parser. So here, example grammar I have taken. Example grammar is, this is the expression is equal to term expression, this grammar. Normally useful, everybody is using this grammar only. So for this grammar, how it will be constructed, the LL1 parsing table, how it will be constructed, we will see here. Okay, so we have already seen how to calculate the first and follow here. So here, I'm not going to explain again the first and follow how to calculate. Please refer the previous video for calculating the first and follow. So here, these are all the first and follow we constructed already. Okay. So here, using this, we need to construct the table. How to these first and follows, using these first and follow symbols, how can we fill the table? Okay. So here, while constructing the table, we need to take non-terminals here. That means variables. These are all called variables also. That is capital letters. So how many capital letters variables are there in total in production, in our productions? That is equal to E, E dash, T, T dash, F. Okay. So those variables we need to take here. And remaining that is terminals we need to take here. So what are the terminals here? This plus star, closing bracket and opening bracket, id, these are all the terminals. And apart from those terminals we need to take one dollar symbol also. Okay, so id is a terminal symbol plus star, open bracket, closing bracket, and $1 we need to take. Okay, these are the input symbols and non-terminals. Okay, first of all we need to check the first of e. Okay, what is the first of e? First of e is equal to open bracket and id. Okay, open bracket and id. So here there is no epsilon, that means null operator is not here, so we need not worry about the follow. Only first we need to fill under the symbol of open bracket. We need to fill the production rule, that is only one production rule is available, that is equal to e tends to te dash. So we need to write same here, e tends to te dash. Okay, and one more production symbol, that is one more first symbol is available here, id. So in the under the column id, so we need to write e tends to te dash. Only one production rule is available, so we need to write the same. Okay, that's all. So we filled the first of e already, and there is no epsilon, null operator is there, so we need not to fill the follow. If in first if you have the null operator, then we need to take care of the follow. Okay, so in e there is no epsilon null operator, so we'll come to the next, that is equal to e dash. Okay, so what is the e dash? First plus and epsilon. Okay, so just plus and epsilon. So here what we need to do, see, under the plus we need to write this one, plus te dash. Okay, under the plus we need to write e tends to plus te dash. Okay, so here we got in first null operator, so we need to go to the follow also. Okay, under the follow just write the e tends to epsilon under these two symbols. Okay, so under these two symbols means dollar or open closing bracket. Okay, so under the dollar and the closing bracket we need to write e dash tends to epsilon. E dash tends to epsilon because we got first in e dash, we got first as a epsilon in e dash. Okay, so if we got the epsilon in e dash in first, we need to fill the symbol of dollar also, we need to take care of dollar also. So under dollar under the follow also, under the follow what we need to fill, we need to fill e dash tends to epsilon, the second production rule, that is e dash tends to epsilon we need to fill. Okay, so here again you see in t there is no epsilon, so we need to take care of only first, that is under this and id, t tends to ft dash, t tends to ft dash. Okay, over. And after that t dash it is also having epsilon, so we need to fill under the follow columns t dash tends to epsilon. Okay, so first of all we will fill the first, that is star. So under the star, that is equal star ft dash we need to fill. Okay, so under the star we filled t tends to star ft dash, and remaining this epsilon we got in the first, so in follow plus dollar or and that closing bracket we need to fill t dash tends to epsilon, t dash tends to epsilon, and t dash tends to epsilon. So, okay, got it. So now look at the f also. F there is no epsilon, so only we need to fill that one first only. So under the column of open bracket, we need to fill this expression. F tends to E, that is equal to open bracket, F tends to E. Under the column of ID, we need to fill F tends to ID. F tends to ID. There is no epsilon, so no need of filling the follow. Okay, this way the compiler will construct the parser table. Here, if you are getting two more options, that means e tends to t dash and one more production rule if you need to fill, then your grammar is not ll1 parser. Okay, if there is two productions under the same column, if we get, so here two possibilities. Here you calculate the first and follow wrongly, otherwise your grammar is not LL1 grammar, then only it will be like this. Okay, so what will happen after constructing this type of table? What is the use of this table? Okay, simply we will see how to accept input from this table. So see here, this table I have constructed here. So by filling the left only, I have constructed by filling the left recursion only, left most symbol only. Here E tends to TE dash. Here what is the left? Here this one. This I again I filled with FT dash. Here F ID and T dash is equal to E. So like that I filled. Here I got the string ID plus ID star ID. Okay, so here I got the string ID plus ID star ID. So using this string, we will see how can we, whether this string will be accepted by the table or not. Okay. So here in while accepting the table, we need to take three columns here. So here we need to take three columns. One is stack, and second one is the input, and third one is the action go to symbols. Okay. So here that is equal to stack, and dollar is first of all we need to take, and here also we need to take the dollar. What is the input symbol? ID plus ID star ID. Okay, with the tree we constructed that one. Okay, with the tree we constructed that one. See here, so ID plus ID star ID. So here we have taken that symbol with dollar is the starting symbol. Okay, and here also dollar we have taken. So what is the starting symbol? That is equal to E. Okay, so under E, after that E symbol, under the input of ID, what is the input here? ID. ID will be the input. So ID, what will the action we need to take or go to, what we need to do in the table? So C in table E, under the ID, what is the production rule? E tends to TE dash. Okay, so that we need to fill. Okay, E tends to TE dash. Okay, so here replace this E with this production rule. Okay, that action we need to take. Okay, so while replacing this, it is a stack. So first of all, we need to send the E dash first. So E dash I have sent first. After that T, okay, the T, okay, TE dash, like we will replace like same only TE dash dollar, okay. Input is ID plus ID star ID and dollar, okay. So here what will be the first symbol? That is equal to T, okay. So T and the input is ID. Input is ID. Okay. So what action we need to do? Whether we need to go to the table, just T, and it is ID. So what is the production? T tends to FT dash. Okay. T tends to FT dash. So T tends to FT dash here we have taken. Okay. So what is the action we need to do? Just replace this. Okay, replace this symbol under the production of T. Okay, I have replaced this FT dash. Already E dash is available here only. E dash is same E dash. We put same like E dash. Okay, dollar, and here F and ID. Okay, go to the table. What is the F ID? In F and ID? Okay, F and ID. So here we got F tends to ID. This rule we need to replace. Okay, so here the rule is F tends to ID. We need to take the action, just replace this. Okay, so under the place of F, ID placed ID, T dash as it is I produced, E dash as it is I produced, and dollar. Okay. Here also input is ID. If ID and ID, two terminal variables are there, just we need to take the action pop. We need to take the action, that is pop the symbols. That means delete the symbols. So here ID and ID I deleted. Okay, so here what is the remaining string? That is T dash E dash and dollar, and here after excluding this ID plus ID star ID dollar, and here we need to see T dash plus. Go to the table. So which action we need to take? That is T dash, and it is plus, that is equal to T dash is equal to epsilon. Just we need to write T dash is equal to epsilon here. Okay, here just that means epsilon, substitute the epsilon, then it will be vanished. Okay, what is the remaining symbol here? E dash and dollar. Okay, E dash and dollar, and here plus ID star, ID dollar, the same symbol, what it is, input symbol. So E dash and plus, the rule is E dash tends to TE dash. Okay, no need to check again and again the table. Here I have written. So go to the table. This we need to take. Production rule, E dash tends to plus TE dash. Okay, just replace this. Okay, so here I'm replacing, that is equal to plus TE dash. In place of E dash, I have replaced plus TE dash and dollar. Here also plus, and here also plus. Okay. So what will happen? Just pop the terminals because both are terminals. So just take the action, just pop it. Okay. Delete. So what will happen? TE dash and dollar, and remaining ID star ID. So it will go on like this. If same terminal is there, we need to pop, delete, and at last we need to get the table, that is dollar and dollar. Then it will be the condition, that is the condition is accepted condition. Okay, the string is accepted if you got dollar here and here also. There is no input and there is no stack symbol is, though both are empty with the dollar symbol, then we can get to a state that is accept the string. Okay, so here like this the compiler will accept the string. Suppose if the table is constructed correctly, and if you calculated the follow on first correctly, if it is LL1 grammar, it will accept like this. So here see some more grammar. Here I have taken this. Okay, here I have calculated the first and follow. So see, so if I want to put the first and follow here, here we got ambiguity. That means S dash tends to ES and S dash tends to epsilon, because here it is the first, we got that epsilon. Here in epsilon, we need to place both rules. That means dollar and E, and here also E and epsilon. Under the E, we will place just S tends to E dash. Okay, so under the place of dollar and E also we need to put S dash tends to epsilon. Here two productions under the same column, then that is called, it is not a LL1 parser. Okay, so how can we know this is not a LL1 parser? Just check the condition by finding the follow first. So if it is E common, we got follow, and first also same symbol we got, that is not a LL1 grammar. And one more thing is, if grammar is ambiguous, if grammar is left recursive, if grammar is that is left factored, then also it will not be a LL1 parser. Okay, so like that you can construct the LL1 parser table, and we will accept the string. Hope you understood. This is very important topic in GATE. Find the grammar, whether it is LL1 parsing or not. So while constructing the first and follow, we will see in first also there will, if there will be two productions are coming under the same first, then also it will be it will not be a LL1 parser. Okay, so hope you understood this. So next class we will discuss next topic.